Suppose the position of an object is given by x equals t cubed minus 9t squared and 15t and 1. Problem A, find the initial velocity and acceleration. When does the object turn around? In order to find the initial velocity and acceleration, we should first do the derivative. The the velocity is expressed by dx dt equals 3t squared minus 18t and 15. And A is expressed as dv dt equals 6t minus 18. And by putting t equals 0 into the functions, we can get the initial velocity and acceleration. For the condition for turning around is v equals 0. So when v equals 0, t equals 1 or 5. And problem B, find the displacement and distance traveled for the time interval t equals 0 to t equals 3. Okay, in order to solve this problem, you need to know how the object moves. So we need to draw this plot. The x-axis is time t, and the y-axis is the the displacement. And when t equals 1 or 5 seconds, v equals 0, and it turns around. So from t equals 0 to t equals 3, we have this function of displacement and this function of velocity. And delta x can be expressed as x when t equals 3 minus x when t equals 0, and it equals minus 9. But the displacement should be what? The displacement should be 3 parts. Or 2 parts, because at t equals 1, it turns around. So we have 2 parts, one from t equals 0 to t equals 1, and the other part is when t equals 1 to t equals 3, and it equals 23 meters. It moves like this. Okay, then we come to the second part. of kinematics. And now let me export the group members. Um, export the group members. Hmm? Okay. Mm. Okay, first take a brief review of the prediction vector, the velocity, and the calculation of acceleration. And we learned the derivative and the integral. And the examples to deduce um, equi- um, the equations of straight line movement with constant acceleration. And then today we will learn tangential and normal acceleration. In order to learn the tangential and normal acceleration, we need to learn the basic concept of natural coordinate system. And the motion function for the natural coordinate system is expressed with with r. Also, the displacement vector r, and it equals s. S is a function of t, and the uh, tangential unit vector e. And the unit vector e is always tangential to the always on the tangential direction of the natural coordinate system. And we have another vector en, always normal to the um, direction. tangential direction. And the velocity for the movement in natural coordinate system can be expressed with this function. V equals ds dt et. And the acceleration has two terms. The first term is the tangential acceleration. It reflects magnitude change of velocity. And the second term is the normal acceleration. It reflects directional change of velocity. Okay, here are the process to deduce the acceleration. And you need to think. Now you need to think why the acceleration has two terms, but the velocity has only one term. Why? Why? Here, I want to know whether anyone knows why the acceleration has two terms, but the velocity has only one term. If you want to see, please text your answer on the chat box.
Hey，我新浪那个还有什么每天都得给他推啊，那上面能接吗？你接下来一年20%、30%。
Just now I leave a question. Why the acceleration has two terms, but the velocity has only one term? Okay, the answer lies in this function. We know that the velocity is expressed as the magnitude of the velocity and et, the tangential part of the velocity. Uh, it is a scalar multiply a vector. And in order to do this dv dt, we learn that it has two terms, right? Et dv dt, and we put v out det dt. So it has two terms. And the first term reflects the magnitude change, and the second term reflects directional change. And we can say for the second part, det dt, at any given moment, given point p, we have here p1, which is the point very close to the p previously to this time point. And we have the later point p2 very close to p. And we can draw this circle. And at any given p, we have this et and this et and t and delta t. And we have a very slight angle, delta theta, and this very slight, very small distance or displacement, delta s. So this is delta et. And when delta t is very, very close to zero, delta theta is very, very close to zero, right? And when delta theta, delta theta is very close to zero, we know what? This angle here, this angle is very close to zero. It means this is the diameter, and this is the diameter, and this angle is equal to this angle. And we know that the three angles ending each other equals 180 degrees. So this is very close to zero. Then this angle is very close to 90 degrees. It means delta ET is perpendicular to ET. It means DET equals d theta En. Okay, this distance is very close to d theta. I hope you can understand. For a triangle or for a circle with radius of 1, this curve equals delta theta. So d et equals d theta en. Okay, having proven this, we can rewrite an as v d theta dt en. And d theta dt equals what? D theta ds dt. And we know ds dt equals v. And the curvature equals rho. So it equals v over rho. And we can rewrite the acceleration like this. dv dt et and v squared over rho en. This is very important for you to solve the problems. For an, an is a normal part of this of the whole acceleration, and it has a magnitude of v squared over phi over rho. And the direction is always normal to the tangential direction. And describe the change rate of direction of velocity with time. And the other term, at, it is easy to understand. It reflects the magnitude change of velocity with time. And the total acceleration can be calculated with this function. Root an squared and at squared. And now I want to think there are different motions, different kinds of motions, and what is the normal and the tangential acceleration in different motions? What is the normal and the tangential acceleration in different motions? Okay, today we have learned a lot of things, and today it is very important for you to conquer this function, the definition of um, the calculation of acceleration in the natural coordinate system. So I I will leave you one homework today, which is to do do the problems on this PowerPoint. Find the normal and tangential acceleration in different motions. In straight line motion, in free fall motion, in projectile motion, and in uniform circular motion, and in non-uniform circular motion. I hope uh, you can email the answer to me by the next class. And my email address is here. Okay, I don't think I'm writing down very. I don't have very good handwriting. Okay, I will text it after class. So today's class is over. You can do the homework and email me after the class.